Have you ever wondered how your phone instantly gets an IP address when connecting to Wi-Fi? That is the role of DHCP. DHCP stands for Dynamic Host Configuration Protocol. Think of it as an invisible network manager that works behind the scenes to automatically hand out the digital coordinates every device needs to communicate. Without this automated process, getting online would be tedious. A person would have to manually type a unique string of numbers into every single laptop, tablet, or printer joining the network. If they made a typo or accidentally assigned the same number to two different devices, those machines would essentially bump into each other and fail to connect. By taking over these configurations, DHCP removes human error entirely. It ensures that when a guest comes over and asks for your Wi-Fi password, their phone joins the network immediately, without requiring a textbook or help desk ticket to get online. To understand exactly what DHCP does, imagine checking into a hotel. The network is the building, and the DHCP server is the front desk clerk, handing you a welcome packet with everything you need for your stay. This diagram shows what that digital welcome packet looks like. The first piece of information the front desk assigns you is an IP address. You can think of this as your unique room number. It identifies exactly where your device is located, so data knows where to find you. Next is the subnet mask. If the IP address is your specific room, the subnet mask tells your device how large your local network floor is, letting it know which other devices are nearby. The third piece of information is the default gateway. On a home network, this is usually your router's address. In our hotel, this acts as the main lobby exit. Whenever your device wants to leave the local network to visit the wider internet, it must exit through this gateway. Finally, the packet provides the DNS server. This acts as the hotel's directory or phone book, translating easy-to-read web names like google.com into the numerical IP addresses that computers actually use to find websites. Providing these 4 exact data points is why your devices can route traffic, browse websites, and coexist on a busy network without constant technical errors. Acquiring this welcome packet happens in a split second through a specific 4-step digital handshake known as the DORA process. Step 1 is Discover. The client broadcasts a message asking for a DHCP server. Step 2 is Offer. A server replies, offering an IP address. Step 3 is Request. The client accepts the configuration. Step 4 is Acknowledge. The server confirms, locking in the IP. In this conversation, the device asking for settings, like your phone, is the DHCP client. The device handing them out, typically your router, is the DHCP server. If the client and server happen to be physically separated in different areas of a large building, a helper called a DHCP relay agent catches these messages and forwards them between different network floors to keep the conversation going. This rigid sequence of messages is how the system maintains order, preventing any two devices from claiming the same IP address at the same time. A critical rule of this system is that IP addresses handed out by DHCP are not owned by the device. They are strictly temporary. This timeline is a DHCP lease. The IP is rented temporarily and must automatically renew. It comes from a DHCP scope, a predefined pool of addresses. But a DHCP reservation links a hardware ID to a permanent IP, ensuring a printer always gets the same address. Leases and scopes act as invisible mechanisms that automatically recycle unused addresses when devices disconnect, preventing busy networks from ever running completely out of room. This comparison table shows the difference between DHCP and static IPs. DHCP handles large groups of changing devices automatically. Static IP requires manually typing in fixed settings. Critical devices like enterprise servers, main routers, and security cameras need permanent locations to provide predictable core services. Even with automation, networks face problems. One common issue is IP address exhaustion. As this grid illustrates, if a network gets too crowded and the scope fills up, the server literally has no more addresses to hand out, leaving new devices completely unable to connect. Other failures happen if the server crashes, which stops new connections entirely. Or if the server is misconfigured with a typo in the default gateway, it might assign an IP correctly, but the device will be trapped on the local network with no way to access the internet. While DHCP is incredibly efficient, its centralized design means that if the server fails or passes out bad information, the entire network can go dark for any new devices trying to connect. Despite these points of failure, large companies rely on massive, centralized DHCP servers to manage thousands of devices, saving IT departments countless hours of manual labor. The magic of walking into a coffee shop and instantly having internet access is entirely dependent on this unseen administrative protocol working perfectly in the background every single time. DHCP makes modern networking simple by automatically connecting devices to networks. Thank you for watching. If this video helped you understand DHCP, please like this video, subscribe to the channel, and turn on notifications for more